All right, everybody, welcome back. Today is our first bonus lecture on core animation today. So let's get started. I'm going to start by kind of describing kind of the basic unit of core animation is what's called a layer. A layer is pretty much analogous to the concept of a view that you're already familiar with. Layers have sublayers, and they have a single parent view, or parent layer, I should say. They're drawn back to front just like views are, and they can specify their geometry relative to their super layer, just like views can. And they're all instances or subclasses of CA layer. And so we'll use layers to build up animations and to build up fairly complicated graphics, contexts, and really some fairly sophisticated composite compositions. Layers, unlike views, however, allow a significantly more complex geometry. In particular, they allow rotations and skewing and scaling and projections. You can get perspective effects. Every view, maybe you probably haven't seen this already, but views themselves already contain a layer. And in fact, a layer by itself can't be put on screen. A layer has to be put on screen inside of some view. So there's there's a really tight correlation between views and layers. Layers give you a little bit more control over the actual content of what's being drawn and kind of the geometry of what's being drawn, but they need to be put inside of a view somehow. So this is kind of how you define the geometry of a layer. There's a CG point called the position, which kind of it's vague, but it gives the position of the layer relative to the super view or the super layer. You can also set the bounds and get a width and height for this layer. If you want the corners to be rounded off, you can set a corner radius for how much for the radius of those corners. And interestingly, unlike views where the frame is kind of a set property, the frame is actually inferred from the bounds, the position, any transformations that have been applied to it, and this funny thing called the anchor point, which is this CG point expressed in unit coordinates. So that means 0, 0 is the bottom left, 1, 1 is the top right, and it kind of the idea is it's supposed to be sort of the how to describe this, kind of the weighted center of the view. Kind of like if you can imagine this being some plate with variable weight, the anchor point is kind of the center point.
It's also the rotation center point.
Yes. So in particular, if you do rotations on a view, it rotates around the anchor point. So it uses the anchor point and the position and the bound sizes to kind of figure out where the actual layer gets drawn and kind of what its actual rectangle is. But yeah, so I'm kind of being really high level about layers. You don't deal with them super a lot. You kind of get them implicitly from their views. One really cool thing you can do with layers that you can't do with views is you can do three-dimensional transforms on a layer. Views, as you may have seen, have a transform property, and this is what's called an affine transformation. Views can only perform affine transformations. Does anybody know what an affine transformation is? So an affine transformation is any transformation that preserves the parallelogramness of the rectangle. So that means that any two sides that are parallel must remain parallel after the transformation. So this includes translations, rotations, and scales, and also like a skew. But anything else is not an affine transformation. So if you want to do a perspective effect, that's not an affine because now you have two sides that are no longer parallel, and that requires a three-dimensional transform. Which this class C, sorry, not a class. It's actually just a structure. CA Transform 3D allows you to make three-dimensional transformations and apply those to layers. There are links at the end of this to kind of this great big document about core animation. I'm kind of just giving you some of the high-level highlights, and you can read the doc to get some more detail. There is, of course, a lot more you can do with layers. I'm not going to go into any more detail about them, but there's a lot you can do with layers, and you can do, like I said, some pretty sophisticated compositing effects with layers. Now, kind of more relevant to animation is that layers can be animated. There are certain properties on layers that can be animated with pretty much no work on your part. things like opacity and the position and the transform and a lot of others. If you look at the documentation for say a layer in the definitions for all the different properties, it will usually say if it's animatable, it will say animatable, and then that means you know. And what's cool about that is now we can, every time we reassign the value of that property, it animates it. It animates that change. So we can do what's called an implicit animation on a layer, where we just reassign the value of one of these properties, say the position and the opacity of this one view, and maybe the opacity of another view. And once we do this, it fires off an animation with some default time. I think it's like 1/4 of a second is the default time, and some other default properties, and it just animates all these changes automatically with no work, which is pretty cool. It's a little bit annoying though, because working with layers is a little bit harder than working with views because they have to be inside of a view, and it's a bit more sophisticated. So typically you don't do much animation with layers. If you want more control over your layer animation, you can actually make what's called an explicit animation, where you create an animation, and see here we've initialized it with the key path opacity, which means that the property we're affecting is going to be opacity. You can have more sophisticated key paths if you want. Again, the documentation explains this pretty well. But we can set things like the duration, the repeat count, whether it reverses back or not, the value we start from, the value we end at, and then we say add this animation to this layer, and it goes off and runs this animation. Again, like I said, it's not super common to do animations with layers because they're a little bit harder to work with. What you're probably more interested in is doing animations on views. And so like layers, views also have a set of animatable properties. Again, these include things like the bound rectangle, the frame rectangle, the opacity, these sorts of things. And with just a couple extra lines of code, anytime we reassign these values, we can have that be animated. So there are a lot of class methods on UI view to perform animations. And rather than explain all of them, I'm just going to demo some of them for you. Okay, so I'm just going to make a new iOS application with just a view. I'm going to call it Stalker. You'll see why. Okay, so let's go into this nib, and I'm going to add. Oh my God, this is small. Okay, so I'm going to make a little view on here. I'm going to make it blue. Go Bears. I'm going to... Now we need a reference to that inside of my... call this my little stalker. And synthesize that. Go back to the nib and link it up. So that's our view controller here. And this guy's going to be our little stalker. And I don't need any of this. Okay, so I'm going to do something really simple to begin with. I'm just going to intercept a touch event and move that little stalker view to where that touch happened. So it's pretty simple. I'm going to say stalker.center is going to be, I'm going to grab a touch event from the set of touches, and then I'm just going to ask that touch for its location. So I click and it moves to where I want. No animation yet, but I'm going to show you it's kind of a stupid little amount of code to do that. So to animate this, there's a class method on UI view, begin animations, give this animation block a name, so I don't know, stock. Context, we don't need a context, so I'm just going to give it null. Then after begin animations, the stuff you want to animate, then you say commit animations. Done. Now it animates. But maybe I think that's a little bit too fast. That's fine. I can change that. I can make this. I can change the speed of that animation. So I can say set animation duration. I don't know, 2 seconds. And if you notice that the default curve of the animation is that it starts out very slow, kind of accelerates toward the middle, and then decelerates back toward the end. I can change that if I want. I can say UI view set animation curve. And there are 4 different curves. There's ease in, which is start out slow and then accelerate toward the end. Ease out, which is start fast and decelerate toward the end. Ease in out, which is the default one, which accelerates then decelerates. And then there's linear, which means it doesn't accelerate at all. But I kind of like the ease in, ease out. So let's do that. Another really cool thing you can do is if you want to. Here, let me go back to the demo. You notice that if I click again before the animation finishes, it kind of springs to where that animation would have ended. If I want to interrupt the animation, if there's any animations in flight that have the same identifier as the one I'm about to fire, I can have it continue from where it currently is running at this exact moment by saying set animation begins from current state and give it yes, which says that once we get 2 animation blocks that kind of stack because they have the same identifier, I kind of interrupt the one that was in progress and then from where it currently is, start the new one. So now, if I go down here and then tap again while it's moving, it starts from where I left, from where it was. So there are, as you probably saw, quite a lot of these methods. You can set, like I said, you can set the curve. You can set a delay if you want it to start only after a certain amount of time. There's a delegate if you want. There's a delegate protocol for handling animation-related events. If you want to have some method get called after the animation finishes, you can pass a selector for that. So repeat auto reverse is kind of it does it and then comes back. Repeat count is how many times it repeats. If you want it to start at a particular date, you can do that as well. A neat one is if you want a view to be replaced by another view, but you want that change to be animated, for example, like flipping over to see another view on the back, you can do that using this transition and then passing the view you want the view that you're replacing. A common example for this is if you have an image view and you want to swap out the image and have it like flip as it animates, you can pass a flip transition for that view and then change the image and it will flip that transition. So just so you can see some other things that are animatable, I can do something like the background color of this view. Color. I can. I really should use my whatever. Okay, so I'll just pick a random number between 0 and 255. 256 and divide by it. So now it'll be a random color every time, and it'll animate through that color change. That's a little slow, I think. I'm going to speed that up a bit. I can reanimate the. I can change the frame. So once I've reassigned the new center, I can have it be. I can make it be a random size, for example. So let's say CG size. No point. What is it? So we'll pull out the center, and then we can say. Center.x minus some random number modulo 40 or something. I have no idea what we're going to get as an effect here, but and let's say random mod of 50 or something, random mod 50. All right, let's see what happens there. Pick some random size. So yeah, it's pretty fun. There's a lot of things you can mess with. A great number of the properties are animatable, and you can see it's not very many lines of code to perform that to add animation to these changes. Okay, so there's been a version of the Clang GCC compiler that was released, I think, a year ago with 10.6 and iOS 4 that introduced a new language construct, and it actually makes animation a little bit easier, if you can believe that, or you get more control over it with the same ease of writing code. So before I get into that, I want to discuss Objective-C blocks, which will come up again on Tuesday when we talk about Grand Central Dispatch. They're actually pretty cool. So, like I said, since I forget exactly what release it was, but there's a compiler that has a new C-level structure called a block. They're basically like functions, but in addition to encapsulating just a function, like in addition to encapsulating code, they also encapsulate data. So they encapsulate the current stack and heap. They are basically closures. So they're basically lambdas in some sense, which is pretty neat. And it's much cleaner than, say, a function pointer in C. And they're actually really useful as a callback method because it contains the code that needs to be executed when the callback happens. So if you have some function some request that's going to take a long time, you can pass a callback for when you're done, call this code, and then it just calls that code whenever it's ready. So this is an example block. Yes, the syntax is really weird, but it's actually pretty neat. So we have this is a function. I'm making a block that given a number multiplies it by 7. But notice that the 7 isn't coded into the block itself. It's declared as a variable outside. So that variable is dynamically bound. So the way to kind of break this down is the first thing is the return type of the block. And then there's this kind of funky thing with the caret. The caret basically means I'm declaring a block. And then the next thing here is the name of the variable that represents that block. In the next set of parentheses are a list of parameter types. And then pretty much everything else is what's called a block literal. So the parameters here and the contents of the block are a literal block. So it's kind of weird to think about, but this part on the left of the equal sign, that's the variable declaration, even though the syntax looks really bizarre. And then this is the actual value of the block on everything on the right-hand side of the equals. So what's kind of neat about blocks is because you can make a literal block, you can pass it into a method, for example, or pass it into a C function, and that code will use that block. And as you can see at the bottom, calling a block is just like calling a function. So this down here is going to print out 21. Any questions about this basic example?
What's the second thing?
This one here?
Yeah.
This is saying that this block takes in as a parameter an int.
You're already telling it that with the parameter names.
Right, but that's not. But in order for the type to be declared correctly, the type has to know about the parameters as well, because this is really just a type declaration, which is kind of separate from the actual block itself. Does that make sense? Okay, so here's an example that uses. There's a library function called quicksortb. There's quicksortr, which takes I believe a function pointer or something to do its comparison. So it does quicksort, but it takes a block to use as the comparison function. So I have this array of 3 strings that are somebody's names. I don't know. I took this from Apple. I don't quite know where these came from. And then there's this quicksort function, which takes in the character array, the size of the character array, and then the size of the elements of that array. And then it takes a comparison block which will do the actual comparison. So in this case, the block takes in a, I don't know why they did a void pointer, but anyway, they cast it. It takes in a void pointer. Maybe the type of I think in order to make quicksort's compilation happy, these probably have to be void pointers. So they probably have to be void pointers, and then you can cast them down as to character arrays down here, and then, for example, we'll return the stir comp of them. Does that sort of make sense? So then this will then sort that array in place. Okay, so now that we have blocks, we can actually do even better animation using some new UIView methods that have been introduced since iOS 4 and 10.6. And these will take in blocks. So I'm just going to look at one kind of in more detail. So animation with duration, delay, options, animations, and completion, which again is kind of long, but it takes in a duration, which is how long the animation should take place, a delay, how long to wait before firing the animation. There is a bit mask of options you can apply to this animation. So these are most of the same options you saw with the set curve. Those sorts of things are all encoded in that bit mask. I think I have a slide on that on the next page. And then the last two parameters are a block for the code that you want to be animated, and then a completion handler for a block of code to be executed after the animation completes. And there's versions of this that omit certain parameters just to make it simpler if you don't need these extra options, but this has everything. So these are all the view animation options. There are lots. You can look at them at your leisure. They're on the UIView documentation page, I believe. Okay, so let's convert that Stalker app to use the block code. So let's comment that out. So let's just start with the really simple thing and just have it move to wherever I touch. So I'm going to call a method. So it is animate with, oh boy. All right, I just want a real simple one, so I'm just going to take animation with duration, let's say a second, and then I'm going to declare a block that returns nothing and takes nothing in as a parameter. So the way you can do that is caret bracket and then the contents of the block. Again, the caret just means this is a block. Since there's no return type or no parameters, I don't need to put anything in parentheses before or after the caret, just because it's a void that it takes in nothing and returns nothing. So I can just put a caret in front of a set of curly braces, and that defines a block. So I'm just going to take this bit of code here, where I assign the center to be the location of the touch. As you can see, the code formatting becomes a little bit weird when you have blocks inlined within method calls. So it's often clearer to actually declare this as a block variable and then use it externally. So the return type is going to be void. I'm going to call it animate. It doesn't take anything. And then, again, I'm being a little bit explicit here, but because you don't need to be all this fancy. So let's actually put this in here. Finish that declaration, and then we'll just pass this to the animate block. And so now it moves to where we tapped. Any questions about this code? And you can kind of imagine how you would modify this method call to use some of these other customizations. You would use the longer method calls to add delays and other options. So I'll stop there. Okay, so that's kind of the highlights of using core animation. There are some great links here to this really in-depth document about core animation, the programming guide. Really useful document about using blocks, because they're pretty cool. When I first started using them, they looked really weird because the syntax is really bizarre. But it's pretty neat to be able to have closures in C, because that's not the sort of language that you would think would have closures. And then also take a look at UI view to take a look at some more of these animation methods and some of these type defs. Cool?